I call upon all nations to do everything they can to stop these terrorist killers. Thank you. Now watch this drive. All right, we need another.
Our group is studying the different lofts of golf clubs and how they may affect carry distance and exit velocity of the golf balls. Before we go any further, it is important to define what loft and carry is. Loft is defined as the angle between the ground and the club face of the club. A loft of 0 degrees would have a club face that is perpendicular to the ground, and a loft of 90 degrees would have a club face that is parallel to the ground. Carry is simply the distance the ball travels in the air. So in other words, the distance from the club head to the first point of impact. Carry neglects the distance the ball travels once it hits the ground and continues to bounce and or roll. Our goal in this project is to show how objects hit with the same constant force at varying angles will have different distances traveled in the x direction, as well as having different initial velocities. Our theory is that clubs with higher lofts will result in shorter carry and lower exit velocities. We will test this theory through experimentation and then prove it through known physics formulas. It is important to note that we are assuming that there is no air resistance and that each golf club is swung on with the same constant force.
Here we have a snapshot of the golf ball being launched by the 60-degree wedge. We can see here that the departure angle is actually 36 degrees. And using a photo software, we are able to find the initial velocity of the golf ball through a system of frames and seconds by using a certain amount of frames and seeing the amount of time it took for the ball to travel through those set amount of frames. Through that system, we were able to find that the initial velocity of the golf ball was 43.296 feet per second. Using the photo software, we were also able to find the maximum height of the golf ball. We were able to use this photo software to see that the height measured was 17.67% of the total length, which was 52 feet. Using the percentage and the total amount of feet traveled by the golf ball, we were able to find that the maximum height was 9.188 feet. Now, we also calculated by hand the maximum height and as well as the initial velocity of the golf ball through the given values of time, distance, and gravitational acceleration. Through a system of kinematic equations, we were able to find the velocity in the x direction, which is constant, which is 29.55 feet per second. Then we were able to find the initial velocity in the y direction through another set of kinematic equations, and as well as involving the gravitational acceleration, which came out to be 28.336 feet per second. Then through Pythagorean theorem, we were able to use both the initial velocity in the y direction as well as the constant velocity in the x direction to find that the initial velocity of the golf ball is 40.94 feet per second. Then, to find the maximum height of the golf ball, we were able to use another set of kinematic equations to find the time at which the golf ball reached the maximum height. Then using that time, we were able to plug it into another kinematic equation to find the maximum height.
Next up, we have the 56-degree wedge. Using the video, we were also able to determine the time the ball was in the air using the same methods as the 60-degree club, only this time we determined the velocity to be around 54 feet per second, which will be significant later. Similarly, the initial length the ball was traveling was determined by using the video to measure precisely when the ball was hit and when it landed, which ended up being about 1.82 seconds. This makes sense that it would be longer than the 60-degree travel time, as the velocity was higher overall even though the angle was smaller. On top of this, the aerodynamics of a golf ball mean that it will stay in the air for longer due to more spin being applied so long as there is more force put into it. Using the length of 55 feet and 8 inches that we found by measuring the distance that the ball traveled by using a measuring tape, we then determined the height, which was interestingly about 19.9% of the length, coming in at just around 11 feet and 1 inch. This is interesting because it is a higher percentage of the length than the 60-degree club, even though that one came in at a larger angle. Now on to the calculated side. We found that Vx and Vy, separately using the time and distance from the video and one of the kinematic equations, respectively, and then combined them together to get the full initial velocity using the Pythagorean theorem, which then ended up being about 42.4 feet per second. This is interesting, as the velocity calculated from the video is much faster than this, whereas on the 60-degree club, the velocities were very close together, both being in the 42 to 43 foot per second range. This could be due to many factors such as the camera angle or a mistake on one of our parts that we did not catch. Lastly, we have the max height, which when calculated using another kinematic equation gave us 13.04 feet, which is similar to the video analysis of 11.1 feet. These values are close enough that we can confidently assume the difference is due to air resistance and the perspective or warping of the camera near the edges. As you can see in the image, there's a 56-degree reference angle, which is what we expected the ball to hit up at. However, the ball only hit at around a 33.6 degree angle, which is to be expected after further research due to the fact that the degree label on clubs is not the actual angle that it will hit off at. This is still an okay angle, however, as the 33.6 degrees is several less degrees than the 60-degree wedge hit at. Each club in a golfer's bag gives them different characteristics, allowing them to select the appropriate tool for each stroke. Multiple variables of a club affect the characteristics of the ball's flight. These variables include shaft weight and length, head weight and loft angle, shape of the club's face, material, and others. Force of the swing is another variable, which will contribute to some error in our calculations, though this was unavoidable. In our experiment, we used the same model of club and ball, negating any difference in material, length, and weight to isolate the loft variable of angle. Loft angle, the angle between the shaft and the face of the club, dictates the trajectory of the ball's flight. If we were to recommend any suggestions to do this again, we would definitely build a rig to place the clubs onto, to make sure there was a more consistent and repeatable force so we would know exactly where the ball was supposed to land for each club. In conclusion, we were able to determine that there was a measurable and predictable difference in launch angle based on the loft angle of the club we were using, which was consistent with the labels on the clubs. This led to a largely differing height, even when the travel distance was very similar. And that is how we showed that differing loft angles cause different initial velocities and will produce different values of max distance and heights when struck with the same force.